Question 13, the graph of y is equal to 2x squared minus rx plus q is shown for the values x goes from minus 5 to 7. Now, the general form of this equation, y is equal to ax squared plus bx plus c. This is a quadratic equation, and we're going to use that. We've only got one equation that we are given, and this is for the axis of symmetry. X is equal to minus b over 2a, which corresponds to these values over here. But what you do know, which what you're going to work also in this first question, where it says the graph cuts the y-axis at 0 and 4. Now, it crosses the y-axis when x is equal to 0. Along the y-axis, x is equal to 0. And so that is when x is equal to 0, we're going to have that these two cancel out. And so this is only c is there. So this is actually giving me the value of c, or in this case that we are dealing with q. So we can straight away write down the value of q is going to be 4, because that is your y-intercept, and that is the value without an x value. So we got that. Then it says the axis of symmetry is 2.5. So we've got this is equal to 2.5. Find the value of r. Now we are given here, because this is y is equal to 2x squared minus rx, and now we know this is plus 4. A is equal to 2. We want to find out what our b value is. So in putting this in here, we're going to get minus b over 2 times 2, because a is equal to 2 is equal to 2.5. So we're going to get minus b is equal to 2 times 2 is 4 times 2.5. That's going to equal 10. So b is equal to 10. Is equal to minus 10, because I put that in there. So we are going to get here, over there we've got our minus r, so we can say therefore our r is equal to 10, because our b, which is equal to minus 10, here we have a minus sign there already, so the r value must equal 10 that we've got in there. So r is equal to 10. Then it says write down the minimum value of y. Now the minimum value is this one over here, and that is actually your vertex, because this is now 2.5. That is your x is equal to 2.45, your axis of symmetry, and that goes through your minimum value, or what we call our vertex. So we've got that as 2.5. We want to find that. So in doing that, I'm going to put this value for x into this equation over here and then solve. So we're going to have y is equal to 2 times 2.5 squared minus 10 times 5 plus 4. So we're going to do that on our calculators. 2.5 squared is actually, it's probably going to be 6.25. So we're going to get 2 times 6.25 minus this over here is going to be 10 times 25 minus 20 plus 4. So we're going to get, this is going to be 12.5 minus 20 plus 4. So we're going to get here, this is going to be minus 16, minus 16. This is going to be minus 3.5. So unless I made any errors in my calculation, the minimum value of y is minus 3.5 there. And then write down the range of y. Now the range of y is from where to where on the y-axis. So we are going here from our x starts off here and it goes to there. Now what about our y? Well, it goes from here, that one over there, which is minus 3.5, and it goes to your maximum value over there. Now, that is going to be when you have negative 5. All right, so we're going to have to put negative 5 into this equation. I'll do it over here. We're going to get y is equal to 2 times negative 5 squared minus 10 times negative 5 plus 4, like that. So we get negative 5 squared is 25, positive 25 times 2 is 50. We're going to get minus times a minus is positive, so that's going to be plus another 50 plus 4. So that's going to give me a total of 104. So the highest value it goes to is 104. So we can see that our range, y, the smallest value that it's going to take is minus 3.5. So it's going to be is greater than or equal to minus 3.5. And the biggest value that it can take is 104. And that will give you your range of y.